Assalamualaikum warahmatullahi wabarakatuh. From group 15, we will begin our project, which is smart waste bin. Okay. So for the group member, so the first is me. My name is Andi and then the second one is Aldass Mohammad Abdullah Ibn Latif. So for the introduction, we know that waste management is growing challenge as city produce more waste and improper sorting cause recyclables, organic and non-recyclables materials to mix together. This will increasing of pollution and landfill use. To solve this, the smart waste bin system automatically will identify and sort waste into categories like plastic, metal, paper, and organic using sensor and motors. So what makes this project unique is that it uses a simple hardware component and without any microcontroller or programming, making it affordable, reliable, and easy to use in school or other resources. So for the objective, we have five objectives to get. First is to design and develop a smart waste bin that can automatically detect the waste and classify it. Second, to implement a relay-based control system that activates sorting mechanism. Third, to provide visual feedback using LEDs to indicate the type of waste detected and ensure the system response. And four, to promote effective and waste segregation at the source, improving recycling efficiency and reducing contamination in waste stream. And the last one is to create cost-effective and scalable prototype suitable for educational demonstration, smart city for the program, and future enhancements such as IoT and AI integration.
For the design methodology of our smart waste bin, we used Autodesk Inventor to create a 3D model before building anything physically. This helped us visualize the concept, confirm measurements, and ensure proper fit between all parts like the bin body, LED holder, and sensors. For the electronics, we used Circuit Maker to design and simulate the circuit. This made it easier to plan out component placement, like the sensors, motors, and relays, and test the system virtually. Overall, these tools helped us work more accurately and efficiently.
So for the design, so this is the mechanical design for the mini project. So for the design, so we have seven part. This is box, base, holder, slide, motor, battery, and bucket. So for the box, so the main electronic part place at there in the box, inside the box, and for the base, act as the foundation, as the holder to secure the rotation bucket, slide to guide the waste into the bucket, motor rotating the bucket, battery main power source, and the lotion bucket can rotating and classify the waste. So this is the box. I mean, so the box there are six parts, which is the bottom one, the sensor for the which is ultrasonic sensor, LCD on-off switch, green LED, and the top cover. So for the materialization, so for the base, I will use wood because it can give a strength, durability, and ease of cutting and shaping, and it can give a effective material that is readily available and easy to work. For the bucket, I will use plastic because it can give a lightweight, durable, affordable, and easy to clean. For the holder, I will use a thermoplastic material, which is a 3D printing material because it can offer higher durability and impact resistance. So for the slide, I will use two material, which is wood for the leg and thermoplastic material for the body. So wood is to give durability, and while the thermoplastic, because I use it because it's easy to work with basic tool. Okay. For the box, which is the bottom box and the cover, both will use thermoplastic material, which is 3D printing. So as we know, This material can give a higher durability and impact resistance, and can give a creating durable and custom shaped enclosure. And the last one is my motor. So for the motor, the end of the motor, we put the rubber. The end shape of the motor will show rubber to increase the friction between the motor and the bucket surface, helping to prevent the bucket from slipping during the rotation.
For the electronic material selection, this slide shows the main electronic components we used in the smart waste bin. We used an HCSR04 ultrasonic sensor mounted at the top to detect waste when it's dropped in. We have also used LCD displays the detected waste type, if it's plastic, metal, or organic. We also placed a green LED light that lights up to show that the system is powered on and ready. These components allow the bin to respond automatically and gives users clear feedback. This slide includes additional important components, which is the on and off button switch, which lets the user to manually power the system on and off. A stepper motor which rotates the bucket to sort waste into the right compartment, and a 12-volt battery powers the entire smart waste bin system. Together, these help control, move, and power the bin effectively. Now, on this slide, there's the lifelong reflections. Um, First off, we developed technical skills, especially in F3D modeling and circuit design. We have also improved our problem solving and critical thinking while troubleshooting. We also practiced time management, balancing tasks and deadlines, and we gained awareness of how technology can solve environmental problems. From the challenges faced and the solutions we implemented, placing the components correctly took careful planning. We had to ensure the bucket rotated smoothly, which we solved by adjusting the motor and holder. Making room for the battery and wires required layout changes, and sensor positioning had to be tested to detect waste accurately. We solved these issues through trial and error, teamwork, and patience. And that brings us to the end of our presentation. Thank you very much for listening. We're happy to take any questions. Thank you.